In this tutorial, we'll look at a great scene by Bertrand Benoit to explain how Railclone can be used to create a render inspired by Berlin's futuristic-looking Chamber of Commerce. We'll look at the techniques to make an almost entirely procedural modular atrium by creating glass facades for the sides, an open-plan lift at one end, plus a skylight and a tiled floor. Even though modular design exists all around us, an issue when reproducing it in CG is that repetition can start to make scenes look unrealistically perfect. To make the environment appear a little more lived in, we'll finish up by examining how to randomize open windows and blinds in the windows, as well as adding texture variations to the marble floor. If you want to check out the scene used in this tutorial, it's available from Bertrand's TurboSquid page. We'll start by looking at how the scene was blocked out. First of all, the majority of the scene is laid out parametrically. However, to be able to create the rest of the model, you should block in the major volumes and anything else that's not repeated more than once. For everything else, splines are created to define the paths for the major components that you can later use in Railclone. For example, there are splines on the sides and the end of the central atrium to describe the path of the facades. There's also a vertical spline at one end of the building to define the height of the elevators. And on the floor, there's a closed spline with sections for the pits that we'll use to create the tiles. And finally, several arched splines over the top to help create the roof glazing. We'll start by creating the roof, and the first thing you need is a tileable section of skylight geometry which has sufficient edge loops to deform smoothly along a spline. The orientation of the pivots is important. The skylight object's local x-axis will be aligned with the direction of the path, and its z-axis aligns to the Railclone object's local z-axis. The easiest way to ensure that the orientation is correct is to just align the object, imagining that the spline's path is along the world x-axis. Finally, position the pivot to the bottom of the glazing bars and then use the Reset X-Form utility to align the pivots to world space. All of the other geometry in this scene is orientated in the same way. Before we start, it's worth taking a moment to understand some core Railclone principles. So Railclone has two types of array, which we call generators. They can be used to create procedural models. The simplest of these arrays is the L1S generator, a one-dimensional array that enables you to duplicate and deform geometry, which we call segments, along one or more splines. You can target 5 separate parts of the array with different segments. So at the start, at the end, on corners which are defined by vertices, at evenly spaced intervals along the spline, and then finally a default segment that fills in any remaining gaps. This type of generator is used in the scene to add the skylight, the lifts and the awnings. So to create the skylight, add a new Railclone object and open the Style editor. Add an L1S generator and wire a spline node to the generator's spline input. From the Properties panel, pick the spline from the scene that's used to define the path of the skylight. Now create a segment node. Use it to load the skylight geometry from the scene and wire the node to the generator's default input. Because this path is to the side of the aperture for the roof, we need to change the Properties Alignment Y setting to top. Then change the Z-axis to pivot to align the bottom of the glazing bars with the spline. Finally, you need to close up the gap between segments that's caused by the horizontal pipe by reducing the right padding value. The elevator shaft at the end of the atrium also uses a one-dimensional array, but this time it consists of 3 different segments. To create it, add another Railclone object and add an L1S generator. Attach a spline node and choose the elevator spline from the scene. Create a segment node and pick the bottom elevator geometry. We don't ever want this to be cut, so disable slice and wire it to the start input. Then finally set the segments Y and Z alignment property to pivot, and we're done with the first part of this array. To add the top of the shaft, copy and paste the existing segment node and then swap the geometry for the top elevator object. Then wire this to the end input. And then finally, to fill in between the top and the bottom, clone the segment node a 3rd time, swap the geometry for the center elevator object, and wire the node to the default input. So RailClone uses the geometry's bounding box to position and space out adjacent segments. This is why the railings are preventing the segments of the elevator from jigsawing together correctly. To fix this, it's necessary to overlap them using the padding property found in the Segment Node's General tab. So reduce the right padding value for the segments in the default and the start inputs until the elevator doors align with the floor below correctly. And that's the elevator finished. If necessary, you can also adjust the length of the spline to change the height of the shaft and refine the overlap for the final segment. Not shown in this tutorial, but the L1S generator is also used in this scene for the awnings and the structure between the skylights. But since that's repetition, let's move on to the floor. For this we'll use RailClone's second type of generator, which is used for creating two-dimensional arrays. It's much more advanced than the generator used in the previous steps, and it's easiest to think of it as a stack of L1S generators. You can target 12 different parts of the array with different segments. The start, the end, corners which are defined by vertices, the top, the bottom, the top, bottom, left and right corners, at evenly spaced intervals along the x-axis and the y-axis, and finally a default segment that fills in any remaining gaps. In this scene we'll use this type of generator to add the floor and the facades. The A2S generator's 2D arrays are built on the x and y axis. Consequently, source geometry should be orientated to these axes too. For vertical styles, including facades, this can cause confusion, but overall source geometry should be aligned as if it is laid flat on the ground. That way, when it's rotated into place, the geometry will be aligned correctly. So the floor tiles are created using an A2S generator that automatically fills an area defined using a closed spline. To make it, create a new RailClone object, open the style editor and add an A2S generator. Wire a new spline node to the generator's clipping spline input and pick the floor spline from the scene. In the generator's properties, enable extend XY size to area. Create a segment and add tile geometry. Wire this to a new transform node and export Y fixed scale. Attach a new random operator to the Y scale input and set the mode to array Y row so that each row has a different height. Now control the scale by setting the minimum value to 40% and leave the maximum at 100%. So to randomly offset each row, we'll randomize the X scale in the first tile only. To do this, add a new transform operator and wire it to the generator's start input. Connect the existing transform node to the new node's input. Open the properties and go to the transform tab. Enable random scale and set X minimum to 25% and X maximum to 175%. To complete the style, we will add some grout between these tiles. For this we need to learn how to alternate between two segments using sequence operators, which can be used to create patterns on both the X or the Y axis. To create a new segment and add grout geometry. Connect it to two new transform operators. For the first of these, export Y size, and for the second, export both X and Y size. Wire the existing random number node to the latter's Y size input and wire a new numeric node to the X size input. This parameter will be used to edit the thickness of the grout. Insert a sequence operator to the default input and wire the transform node to its first input. Wire the tile to the second input to create a repeating pattern on the X axis. Now, insert a second sequence operator. Change the increment at setting to Y and attach the other transform operator wiring the numeric node to its Y size input. And then simply repeat this last step for the start input. You now have a floor with randomized tile heights on the Y axis, a randomized offset on the x-axis, and an adjustable grout size. With the geometry complete, we'll add and randomize textures. So RailClone can automatically apply UVWs to segments by enabling Apply Box Mapping in the Segments Deform tab and entering a length, width and height dimension. To create a more realistic floor, we can randomize the tiling and the rotation of the UVWs to create nearly limitless variations. To do this, wire a UVW Xform operator after the tile segment and enable random tile. Set U and V minimum to 8 and maximum to 15. Turn on rotation and set the maximum to 360. For more variety, you can also use a RailClone color map to randomize between different bitmaps and even add a random tint. Now let's move up to the facade. Add a new RailClone object and another A2S generator. Attach a spline node to the X spline input and use the spline that's the length of the atrium. To set the Y size of the array, use the generator's size value. Now to add the ground floor, create a segment, pick the base geometry with the unglazed wall from the scene and then wire it to the bottom input. Change the alignment for all the axes to pivot and again turn off slice, we don't want to slice this geometry. At this point, you'll notice, as we mentioned earlier, that the array is created on the XY plane. So to rotate it so that the facade is vertical, change the generator's X rotation value to 90. Now we'll add the other floors. So clone the existing segment and pick the geometry to be used for the bulk of the facade. Wire it to the default input. As we saw with the elevator earlier, there's some geometry preventing the segments from jigsawing together correctly. So fix this by adding transform operators to both segments and adjusting the top padding values until they lock together correctly. And finally, to create the top floor, we'll clone the existing segment again and then pick the geometry to be used for the top of the facade. Wire this to the top input. But this time note that the overlap is also slightly dependent on the Y size of the array, so this may need adjusting at the end as well. So it's not quite as simple as that. There are actually 3 facade models for the ground floor, a blank section, one with an open window and another with a door. And for the main facade, the rest of the facade, there's a section with a window which is used everywhere except for where the elevator meets the facade, where a section with a door is needed. We can easily control how these are placed using spline IDs. So to set this up, you want to wire a selector operator after the existing default and bottom segments. Change both selector nodes' modes to spline material ID. Then duplicate one of the existing segments as many times as necessary to import the other facade segments. With all the segments imported, you can wire the default segment with the window to the first 3 inputs of the selector operator, and then wire the door segment to the 4th. This is for the default input. What this means is that you can now use the spline material ID 1 to 3 to create a window section, and ID 4 will create a section with a door. So now we need to do something for the bottom input. So we'll wire a blank wall section to the first input so that spline ID creates that. We'll wire a door section to input 2, and then for 3 and 4 we'll use the window section for both. To make sure when we add vertices to change the material ID that the geometry isn't sliced, go to the generator's bevel mode and set it to none. You can now go in and refine and edit the material IDs on the spline to control the choice of segments used on the facade, using ID 1 to create a blank wall on the bottom row, ID 2 to create a door on the bottom row and windows on the middle row, ID 3 to create a window on the bottom row and windows on the main facade, and use ID 4 to create windows on the bottom row and doors on the main facade. So we're nearly there, but we want to break this up with some subtle variation. To do this, we can randomize the amount that each window is opened. So there are 3 windows in the scene at different angles. Their pivots are positioned so that when aligned with the facade's geometry, they're already in the right place. To add these to the graph, import them into cloned segments and wire them to a randomize operator. And then to combine them with the windows, insert a new compose operator after the selector in the default input and the segment in the top input. The compose operator is used to combine multiple segments so that RailClone processes them as though they are one. It has two modes. Sequential mode places items one after another along the path, and grouped mode, which is what we want, aligns all of the geometry to the pivot point of the segment wire to the first input. So change the mode to grouped and then wire the random operator to the selector node's second inputs. Random blinds or curtains can also be added using exactly the same technique. There are 4 blind configurations which should be loaded into segment nodes. Once that's done, wire these to a new randomized node and wire the randomized node to the third input of the existing compose operators. Each facade section now has a window with a random angle and one of 4 possible blind layouts. These additions can really help to break up the repetition of the modular architecture and bring the environment to life. Our final step is to trim the facade so that it fits the curvature of the roof, and for this we use RailClone's Boolean clipping features. To create a closed spline that outlines the shape of the building section. Add this using a new spline node to the RailClone graph and wire it to the clipping spline input. In the generator's properties, change the clipping area mode to include and the projection to Y. At the beginning of this tutorial we disabled slicing for all the segments, so now we've got to change the for no slice option to slice in the clipping settings. This will force slicing the geometry but only by the clipping path. To create the other side of the atrium, you can duplicate the existing RailClone object and its spline, but then you've got to mirror the geometry. So if we were using the L1S generator, we'd have a simple property for this, but for the A2S generators, you'll simply need to add mirror operators to all of the geometry inputs. And that's the tutorial complete. We hope you enjoyed it. If you'd like to learn more about RailClone or you'd like to watch more in-depth tutorials about procedural modelling, please visit our website.